I hacked Amazon not once, not twice, but multiple times into my bug bounty career. And also TikTok, Google, etc. and other big companies. The only one vulnerability that I love to look for or one of the common vulnerability that I found across most of these programs that I just mentioned, which is cache deception. It's very easy to find it if you have the right methodology and the thought behind it, and you understand the technical knowledge behind this exact vulnerability. So this video is going to be divided into 3 parts. The first part, I'm going to explain how cache poisoning and what's the relation between cache poisoning and cache deception. And the second part, I'm going to get you through the thought or the methodology for me, how I usually find this vulnerability. And the third part and the last part, which is going to be me solving some realistic lab that I have built from my previous report for this exact vulnerability. So if you want to skip some part and go directly to the practicing this lab, you go ahead and do it. So if you're interested, please click the like button and the subscribe button, and let's just get started. Before we talk how cache deception and how cache poisoning actually work, you need to understand how web application actually function and what is the difference between modern web application and just a simple web application that they just built just to host some page, or real world application, how they function. So let me break it down to you. So let's just say you are a user, or there is someone is trying to visit your website. So this is the like the usual case, or the most famous case. That's how the web work. For example, you're the user and this is the server. So the user is going to send a request to the server, and the server is going to come back with a response. Okay, so user going to send a request to the server, then the server is going to process this information. Then when it's going to process it and knows what exactly the user needs, it's going to come back with a response to us. For example, we want to see a picture. He's going to see, okay, what kind of picture? Picture 1, picture 2 is going to give us this picture. You want a JavaScript file? Okay, so what kind of JavaScript file? He knows, he goes grab it from the server and he's going to send it back to us. This is how usually a web server work, or web application actually work. So the only thing related between cache poisoning and cache deception, which is the word cache. So what is actually cache, and what do we actually mean by the word cache? The word cache, there is something called a cache server. So what is actually a cache server? So a cache server basically is like a server that just considered as a RAM into a computer. They have to store some files for a temporary period that way. So okay, so the next time when you actually try to visit some website, this website, he won't actually come back with the data to you. He will go through the cache server, then come back to you. You might be wondering why this is happening, why it's going through a third party, then it's coming back to us. Let me tell you exactly why. So there is in the web or web application, they have something called static files, and they have like files that can be changed by the time. Let me give you a small example. For example, a crypto application, they have a prices that gonna be changed from a minute to another. Not from a minute to another, from a millisecond to another millisecond, that fast. So these data actually needs to be updating all the time. But in opposite, let's just say a JavaScript file. So a JavaScript file doesn't need to actually be updating, or CSS file doesn't need to be changed time to time or every time we visit this page. Or let's just say a picture. A picture is just a picture. It doesn't change by the time. So the developer said, instead of a user every single time coming back to the original server that have all the operation behind it, so they created something called the cache server. So now the data, instead of just going directly to the user, he will go to the cache server. So this data that comes to the cache server is not like the updated data. So this data specifically that comes to the cache server are the static file, like the JavaScript, the CSS, the pictures. So the next time when we want to get a picture, especially these files, if they are so big, we want to send a request to the server and send it back to us every single time, because that's going to make the server very slow. What we want to do is we're going to save this data into a cache server or into a temporary temporary data for maybe an hour or maybe 24 hours. It depends on the configuration. So that's like time to die, or this is something like configuration saying to the server, you need to delete or erase this data for a specific time. Okay. Next time when we try to visit, or we ask for this picture, or ask for this JavaScript file, or ask for this CSS or whatever, or this static file, it's gonna be not going to the server, but me or our browser is gonna go to the cache server and connect just to the cache server. But if he wants something like an API call, for example, something needs to be changed, for example, an API that needs to be changing the price or something related to this, he needs to go to the main server to get these data. So basically, this is how the cache server works. So now let's talk about cache poisoning and cache deception. So let's just imagine a user or a hacker is able to store some malicious data into that server. So now whenever other users is gonna come back to the cache server, they're gonna be seeing the malicious data that the hacker actually stored inside. So you might be thinking how this is even possible. So usually the attacker needs to find a way, or needs to find a misconfiguration into the cache server, whether it's by injecting a malicious header on the HTTP request, or maybe he can actually inject some malicious link inside the body of the HTML that is going to lead to a stored cross-site scripting, etc. Now let's just talk about cache deception. So you remember when I told you the part like the user needs to be like the server is going to be storing files like CSS, JavaScript, images. So that's the most important file. That's the most important thing that the attacker needs to be exploiting. Let's just say, for example, we're having a web page, and this web page that have like settings that contains our phone number, contains our email, contains our API keys. So the attacker, what he usually say, or what he usually tries to do, is try to convince the server or the main server this is a cacheable data, or this is like a real cacheable data. And how he actually do it is very smart, is by doing or injecting like .css or .gs or .movie or mp3 or all these extensions. You can find them online. Like you can go most websites like Hacktricks. He have all the extension you need to be looking for, and sometimes you need to be adding some Unicode or adding some, like for example, like %22 or %00 in order to bypass these filters. So now what the attacker actually can be doing, he will just grab this URL like /settings.css, and he will open it into his browser, and he can see the settings page of the victim. So the attack scenario basically will be like this. The attacker sends a malicious link to the victim clicks it on an authenticated session, and that session is going to be storing his data to the cache server. Now, the attacker needs to be just visiting this malicious website that is really being cached by the victim, so he can see the data has been stolen. So that's the difference between cache poisoning and cache deception. So now let's just move on to the practical app. So now we are into hackers.space platform. So if you don't know this platform, so basically it's a platform where you can actually see bug bounty courses and web ethical hacking course, and we also have some practical labs. That's what we're going to be doing right now. So you need to go to the lab section right here, and the hard part, like we have some levels to go through, but that's the hard part, lab. And you go to the web cache deception, and you have some room right here with an explanation. You have a doc vault when you can actually explain to you what you're going to be doing into this lab right here. So basically, I'm going to explain to you what is going on, or how the scenario that I was facing for this exactly vulnerability. Like when I was testing into this application, I had a functionality when I can upload some private document like an AIN, like just say an LLC or a passport number. So now I'll just open this link right here and let me show you. For example, you can see this. We have a doc vault, which we can actually upload some private files like an LLC formation certificate, IRS EIN confirmation, and a business bank wire instruction. information, etc. So we have all these private files, as you can see right here. We have an IRS information, you can see a business bank wire, but this is not our main thing that we should be looking for. You can see right here we have a document ID, and when we click into this document, you can see it's gonna come back right here. So I said, okay, so I have a sensitive information right here, so I need to be tricking the server into caching this data into the cache server. So what I did basically is I tried to, let's just open this into Burp Suite in order to see how things are going on the background. So let's just go into Burp Suite and see where is our lab. For example, let's do this. So this is our web page, and send it to the repeater. So if we're going to send this to the repeater, you can see it's a normal page when you can send a request and you have some data like document, etc. But if a hacker actually wants to trick the server to think this is a static file, this is not a normal page, this is like JavaScript or this is like CSS, he's gonna try to do, for example, something like .gs. Now he's gonna try to click it, and as you can see right here on the cache, you can see cache control public, and we have a max age. If you see something like this, like a max age right here, so that is the time that this request or this storage is gonna be dying. Okay, so that's the age of this file is going to be stored into the server, and this is the most important part right here. So you can see xcache and miss. If you're gonna send this request again one more time, you can see hit. So hit means that this data or this page is stored into the server. So let's just open this link, okay? Copy URL and open it into a private window and see what's going on. So if you open this link into a private window, you can see we have stored this file as JavaScript into the cache server. And as you can see, we have an ID for it right here. You can see we have all these private information, AII number, entity, etc., etc. So, and also we have the capture the flag. We have the flag right here. You can actually submit it and solve this lab. But that was not enough for me to just cache this page and submit a report. You know why? Because you can see right here, this ID is not guessable. Like, how can you actually send the link? So the attack scenario behind it, you're just gonna copy a link, send it to the victim, and we need to actually know the link and we need to just guess this data. But I did not know this ID. So what I tried to do is I thought, okay, so if this page is vulnerable to cache poisoning, basically there is another page is vulnerable to the same vulnerability. So what I did basically, I just go ahead, let's just come back into our lab and just come back to the document page. And on the document page, there is something very interesting, which is it contains the ID. So our idea, or my idea, was to just also cache this page. So let's just come back right here, and I want to cache this page too. So what I want to do is I'm going to refresh this page, come back to Burp Suite, intercept this request, send it to a repeater, and click send, and you can see this page is normal. There is no miss hit on the response. But if we try to trick the server, let's just say this is not a normal page, this is a CSS file, so you need to store it into the cache server. If you're gonna click send, you can notice right here that we have new like headers, like we have a xcache and we have the max age. If we're gonna send it again, it's gonna show hit. And I said it before, hit means that this data now it's stored into the cache server. So basically, you can see it right here. So this data is stored into the cache server. So let's just open this link, okay? Copy URL and come back and open it into a private window and see if this data is cached. And as you can see, this data is cached. So you may be thinking, okay, so now what we should do, we should just send a victim two links, or what we should be doing. No, you should not send the victim two links, because that would not be like an attack. That would be like more of a social engineering more than an attack. So I came up with a way is to make a malicious HTML page with a malicious JavaScript that is going to open the first link. Then we're going to grab this ID that we just stored, because if you're going to come back into our lab, you can see this ID is the same ID like stored right here. So that's the ID number 1, ID number 2. So if we stored this page like /document, now we know the ID. And the second thing is we can guess the last URL that we just did. We can guess this URL and open it again and store it. So that was the logic behind it. So if we're gonna come back into our lab right here of hackers.space, if you're gonna come back right here into the hint, you can see that I have that static file right here, which is like a POC. I don't recommend going and just try for a POC. Try to build this JavaScript by yourself and try. Now you understand how the bug works. Try to build this HTML page with yourself. Let me show you now what we're gonna be doing. Okay, so this is our page right here. So what I want to be doing is I'm gonna copy this, paste it, and let's just come back, copy the POC file right here, and I'm gonna open this link into the attacker session, into the victim session. Okay, so basically I'm gonna open, so this is my POC, or like proof of concept. So basically you can see cache deception exploit. So I'm just gonna copy the domain because it's random domain for each lab. So basically I'm just gonna put it right here. So in a normal case scenario, you know the domain. Basically I did this just as a POC. Normally how does POC work? You just send the link and it will automatically open link 1 and link 2. But in this case, as the subdomains change based on the lab or the CDF lab, I just made this POC just for you. So you can see right here we have exploit. So when we're gonna click this, what will happen is just as I explained. It will try to open this link, open this page, like store this page. You can see hit, then it will get the ID or grab this ID right here. We'll grab it, then it will put it into here and put .gs and store this page. Then we're gonna get this page. This is how it worked. So let's just cut back into our lab and click exploit. You can see right here all the steps. Like you can see right here, we have xcache miss. Now we got leaked the ID. So now we leaked the ID, and now we open this link with the ID with the .gs. As you can see, xcache miss. And now we're having a document, and as you can see right here, we have cached the victim session, which is this one right here. You can see LLC formation. If you come back again and open LLC formation, you can see this ID. I'm gonna copy it again and do Control F. You can see we just grabbed the victim ID. So that was the scenario, and that was the thought behind it of this cache poisoning. Or sorry, that's cache deception vulnerability. Thank you so much for watching this video. If you like this kind of videos or this kind of explanation, practicing practical labs and actually explaining how vulnerabilities actually work, let me know in the comment section. And also if you want to learn about hacking and actually access to the labs that I showcase into my videos, you can join hackers.space when I explain multiple vulnerability types or multiple attack scenarios like bug chaining, IDORs, XSS, stored XSS, cache deception, etc. You can find the link on the description. And also you have some practical labs to practice on your skills, and also a community when you can chat and discuss with other hackers, especially me. I'm gonna be there 24/7. So if you have any question, you can ask me directly to me. And thank you again for watching this video. Don't forget to click the like button, subscribe, and see you in the next one.